All right, ladies and gentlemen, welcome back. So, one quick thing I wanted to mention before we moved on from action potentials and into another way in which they work is just the idea of going back to that action potential and connecting it to the neuron's structure itself. So, one of the things that's kind of interesting about axon structure in certain neurons is that they also have these myelin sheaths. And what those are these little sort of bands, insulation bands, if you want to think about that. And what they do is increase the speed of the action potential based on the axon's diameter. So the smaller the axon, the more resistance to flow of electrical current. And if you know anything about the way electricity works, it's the same way with wires in your house. So we're not going to send big high tension electricity into your house. We'll do that by bigger, fatter wires hanging on the telephone poles in the streets, and then we'll size it out accordingly based on what every home needs. And the same thing going to different appliances. So if you were to look at the cord to say something like your washing machine or to your refrigerator, they tend to be much bigger, bulkier cords because they're carrying a lot more electricity in them. So your neurons work the same way. So it's inversely proportional to that cross-sectional area. So in order to speed up those action potentials, certain vertebrae have axons in their body that are insulated by these myelin sheaths, and those myelin sheaths are going to increase the diameter and as a result increase the potential action potential's speed. So where do they come from? Well, they're made from those glial cells we mentioned, specifically oligodendrocytes in your central nervous system. And if we're talking about axons that have these myelin sheaths in your peripheral nervous system, then they come from those Schwann cells. And what they do is they allow those action potentials to only form at these things called nodes of Rodanthe. So rather than needing to send that action potential literally through this entire stretch, they'll jump those axons, or excuse me, those myelin sheath cells, those Schwann cells, and only send those action potentials here. So it's sort of like taking incremental steps to get from your bed to your bedroom door as opposed to taking big leaps across your room instead. You're going to get to the door a lot faster if you take those big leaps across the floor as opposed to taking those tiny incremental steps. So what this does is it allows the action potentials to jump those nodes, allow the potential to get across that axon much quicker, and this whole process is called saltatory conduction.